One last compressed instruction to go, the CLDSP. So what is that? Let's check out this helpful diagram. CLDSP, up we go, looking for an L, and down here we have C, nothing, load, double word, using stack pointer. So that's what we're looking for. And what does this expand to? Well, it expands to just a normal LD, load double word, S0, is the destination, and 8 plus SP. So SP plus 8, go to memory, pull it out, stick it into S0. So there's nothing too complicated here since we've already seen CSDSP, the store. This is just the load instead. So it's going to memory, parentheses means going to memory, starting at SP, the address in SP, plus the unsigned immediate 9, and it plucks that value out of memory and stores it into the RD register. So again, just a different way of showing it. SP plus the 0 extended unsigned immediate 9, and pull it out of memory, stick it into RD. This UM9 is also scaled by 8, just like with SDSP. So again, it's a 9-bit value, but only 6 bits are actually in the instruction stream. And so it's going to be multiples of 8, 0, 8, 16, etc. And that's pretty much it. That is it for all of these new compressed instructions. So like I said, I want to cover these early in the class because we are at like this simplest phase right here, right? And so if even this simple code has this, then as we get to more complicated stuff, you'll actually see this stuff coming up again. And we also talked about how this is just basically setting up the frame pointer, and this is just tearing down the frame pointer. So you're going to see it over and over again unless you explicitly optimize to a level that doesn't use frame pointers or explicitly say don't use frame pointers. So just to recap, like how you can read these as you continue to see these every time we invoke the chaos magic and get rid of the aliases, you will see these things pop up, but you can just treat them as, okay, compressed addi, it's really just an addi where the source and destination are the same. SP minus 16 back into SP. SDSP can pretty much just ignore the SP and read it like an SD instruction. So store S0 into SP plus 8 in this case. So just treat it like a SD. Add I for SBN, well, that's really just an addi. The times 4 is just already encoded in here, so you don't need to care about the times 4. Just if it says it's 16, it's 16. And the SP just means it's hard-coded and using the SP register, so just read it like a addi. So you have SP plus 16, store it back, like add those together, and store it back into S0. Compressed move, well, that's just like a normal move. Move that register value to that register. And C.LDSP, again, ignore the SP. That's just, it has to use that to hardcode the SP because the compressed version of LD can't, specify SP. So just ignore that and just read it like an LD. So it's loading from memory, SP plus 8, go to memory, pull it out, stick it in S0. And that's it. So these are definitely all things where it's easier to read them once you know the encoding and you just, don't care about particular suffixes and stuff like that. While the suffix is trying to tell you something about it, when it comes to reading, it's easier to just kind of ignore that stuff and read SDSP like SD, add I for SPN like add I, and so on. All right, so at this point in the class, we have picked up 4 instructions, 5 pseudo instructions, and 6 compressed instructions. So what do we got? We got compressed SDSP, which is really just an SD. Compressed LDSP, which is really just an LD. Compressed add I, which is really just an add I. Compressed add I for SBN, which is really just an add I. Compressed move, which is really just a move. But move is really just an add I. But of course, it's easier to read it as a move, right? If you just say, okay, move the value from that register to that register, that's easier than having to think about what it would be as an add I.